Hello, this is the first video after quite a long period of time, unfortunately. I've had a few problems going on with health and various other things, so I'm back to normal a bit, and I've been working on, as you probably heard, a 6809 emulator adapter board, and I'm pleased to say that the prototype is now running. This is a little sneak preview of the actual board and what you can sort of do at the moment with it, though there are going to be obviously some improvements to the functions, but at the moment it can do all the basic stuff. So this board I've got in front of me is a Cobra command board from 1988. It's a jammer board made by Data East, and it's effectively a working board. And the reason I picked it was because I haven't got many boards with 6809s in, but this one actually has, and it's in a socket. Now, there is a difference. This is actually a 6809E processor that's in this board, and the emulator adapter I've developed is actually based on a 6809E. The E version has an external clock signal, whereas the 6809 doesn't. It obviously just has a crystal and generates the clocks itself. So you can't put one into the socket or another one, etc. It doesn't work. So this is actually working on an E version, which is quite important. And the board is obviously there. You can see the processor has been taken out, and my breadboard version of the prototype, which I do with all of them now, is plugged in. Now this has taken a bit of time to develop, and if I zoom in you can see just quite how complex this thing can get. It's got a 6809E sitting in it, and it's got a load of buffer chips and various other things, and this handles all the timing. So the tester, which is hooked up, you can see there, is just going down the usual ribbon cable. There is another little cable, but that's obviously going to be incorporated in the one that will finally be released, right? But this is obviously just a prototype, so you've got to bear that in mind. And it takes over the place of the processor, so when it's plugged in it works like any other adapter, but it also has the emulator function as well. Now if I power it all up, at the moment I've got nothing on the screen. I'll power the board up. Excuse the mess in the background. You can see I just get static, and that will what you'll get, because when this starts up it goes into the adapter mode to start with unless you tell it otherwise. And you've got two LEDs on at the moment. One's a power one and the other one indicates that the processor is in a tri-state mode, which is quite important because the tester now has control of all the buses. So the board's powered up, the emulator's plugged in, the tester's sitting idle. If I go to the screen, I've also got a coffee, which is very important with these things. You can go to the screen, and what I will do is set the tester, which is now 1.8 beta, right, to 6809, and it comes up and says microprocessor set to 6809. When you do that, you've then got control of everything. So I can do, say, map, and you can see it will come up. Now the 6809 is a little bit different to a Z80, etc., whereas all the ROM, etc., is at the top end of the map, and the RAM, if you go down it, you can see you'll have a little bit where it's gone blue, that's not used, and then you've got the RAM which starts at address 0. And in this case, on the Cobra command, it goes up to 37FF. Now the thing is, it can't detect which is RAM and video RAM, because I think the video RAM is handled by some flat packs. So from the processor's point of view, it doesn't make any difference, it's just RAM. The flat packs obviously do all the switching over and the clever stuff. So it doesn't matter, because the tester will still pick it up as RAM, and you can still read and write to it as normal. So this is in an adapter mode, remember. So for example, I can do all the usual things, like I could set the address to 0, and we could set, say, bytes to, say, I'm just going to do some basic little things to show you what it can do here. Do it to FF, block read, you can see the RAM is currently full of rubbish. Write again to set it back to 0, and what we'll do is we'll write zeros in, so do block write, go back, and now you can see the RAM has been loaded with all the zeros. So you can read and write RAM, you can play around with the video RAM, you can change the colours, whatever. If you know the spec of the board and where things are, you can do all that. You can also get all the interrupt vectors and the reset vectors, which are held at FF F1, we'll say, and we'll do a block read of F, which gives it the last 16 bytes of the memory. So you can see I'll get some data back. Now it's held in ROM, and this is the reset. You got like the reset vector, which is those two there, 800. So what happens when we reset the processor, it will go to 8000 address to run the code. That is one of your interrupt vectors. You got another one and another one and another one. So you can read all the vectors with it as well. What else can you do? I could also do a RAM test. Again, just because it's all obviously running as an adapter at the moment, you can do pretty much everything you normally can do, insert pins and things like that. So if I do a RAM test, we'll set that to 0, it doesn't make any difference, but set the address to 0, and then do a RAM test, which will test, say, let's do 1000, and that will test 4K of the RAM. Sorry, my camera moved a bit there. There you can see. So it's testing the RAM, and it's passed it. So you can test RAM, you can read ROM, you could obviously read the ROM and store it as bin files, which you could put into a mini pro, etc., and program EPROMs. You can also use that to program EPROMs with the EPROM programmer for the tester, which will be released soon because the PCBs are now getting built, and then we're going to have to test them. So you can do all that. So that's really all working as an adapter, so it gives you all the usual things you can do. But certainly with the emulator you can do other things. So if we did reset, for example, it will emulate reset, and then if I type run and I hold over there, you'll see the game starts up. I'll zoom out so you can see a bit more of it and all the rubbish around it. And if I do reset again, you can see it resets the game. Colour is a bit funny, but it's probably because I muddled around with things, but it does actually work fine, as you can see. And also you can also stop it. So for example, if the game starts like that, you can just stop, and then you can type run again, and it will carry on where it left off. Every time you stop it, you can then use it as an adapter. So you can go in, you can check the memory, you can see what's been written to various locations, and then when you type run, it can carry on. But when you're in run mode, you can't use the adapter functions because it locks you out. So you can either do one or the other, but it will switch seamlessly between the two, as you can see. The other thing you can also do is you can stop it. As you can see, we'll go back to the tester. I'll zoom in so you can see what's happening here. Hopefully this won't move too much. I'm trying to balance the camera with one hand and type with the other, so it's not very easy. One of the things you could do with the emulator, the software is not fully working yet, but it does work, is we can say, whoops, if I type pause, like so, whoops, if I spelt it right it would help. It puts the tester into a wait mode effectively, which means the processor is still sitting idle, but it's now waiting, right? So if I do a reset, you can see it's reset. Now nothing will happen on the screen obviously, but the important thing here is there's a command you can type in. This is a low level AOS command. You can type star plus 03. Now the software will be improved to do this, but this just shows you what it can do. If I do star plus 03, I get a number back 32768, and if I do star J, which converts that to the actual address, you can see I get address 8000. That is very important because when you reset a 6809, it goes and gets an address at the reset vector, which is what I looked at in memory, and the memory location then indicates 8000, which is 8000 in hex, and that is where it will start its program code. So now if I do a star plus 03 again, which is another step, you get 3270, and do a star J, you can see it's 8002. So what you're doing is you're actually single stepping the program code by doing this. And if I did a reset and did that again, it will go back to 8000. Now there is another thing it can do. I'll do that again. It might do it on this. It does. You see now it's jumped to 40580. Now if I do a star J to that, It's come back with 9E84 for an address. And you think, why has it done that? Has it jumped off there in the code? No. What this has actually done is it's got an interrupt. The process has been hit with an NMI interrupt, which means it can't do anything about it, it just has to do it. And another one of the vectors at the memory locations we looked at is for an NMI vector, which will, if you look at it, point to 9E84. So when it gets its interrupt, it's now gone off to service the interrupt at address 9E84. And if I do a star plus 03 again, what it's going to do, and a star J, you'll see it will start stepping through the code of the interrupt vector, or the handler. Now the emulator can do this. It's got a special circuit which only allows it to get one instance of the NMI because it gets them all the time. So what will happen is when it gets one of these interrupts, it will go off and it will allow you to step through the code of the interrupt handler as well. You do have an option on the emulator that you can disable that, so you can just step through the game code without the interrupts being acknowledged. And you can also run the game code without interrupts as well. So you can choose whether or not to have the interrupts enabled or not. Obviously, if you run the game without the interrupts, you probably won't get much happening on the screen. But if you do enable the interrupts, what will happen then is when you step it, it will step through the game code, but then it can just jump off to service an interrupt. And it lets you see all this and you can step it all. So you can see it's quite versatile. Well, obviously now it's all working, I'll improve the software so that what will happen is it will allow you to sort of do it a bit easier than what I'm doing here. But you can see the principles are all working. So this really is a little sneak preview to show that the prototype of the 6809E emulator adapter is now working and has been tested, and will now go to PCB stage where we'll get some PCBs made up, and then hopefully later in the year these will be available if anybody's interested. They will work on pretty much most testers. At the moment they work with Mark IIs and 2.1s. They should work on a Mark I as well. So they're going to be compatible with everything. The software just needs to be updated to handle them, and then you're good to go. The other thing is the Z80 emulator is now getting built on a PCB, and once that has been tested properly, then they will be available as well. So it's just a quick little update to let you know what's been going on. Okay, thanks again. All right.